Across North America, spring has sprung. As the mercury rises, the winter snow seems like ancient history. Not so for NASA's Operation IceBridge scientists, who continue to brave Arctic temperatures at Thule Air Base in northern Greenland. Since mid-March, the IceBridge DC-8 aircraft has flown the equivalent of 1.5 times around the Earth, logging more than 60,000 kilometers and 100 flight hours. The purpose of IceBridge is to provide data about the Earth's polar regions, allowing us to monitor change in ice cover. IceBridge scientists accomplish this by measuring the ice with a variety of instruments aboard the fully equipped DC-8 aircraft. A typical flight day for IceBridge begins at 6 a.m. The ground and maintenance crews meet at the hangar to power up the plane and ensure it is a successful 8-hour flight. Once the DC-8 is towed out to the ramp, the IceBridge pilots and team of research scientists prepare for takeoff. Throughout each flight, scientists manage 7 state-of-the-art science instruments aboard the DC-8. Several instruments, such as the Airborne Topographic Mapper, or ATM, utilize laser altimeter technology to measure the surface of the ice. 3 radar instruments from University of Kansas measure the vertical profile of the snow and ice. The KU band and snow radars measure the depth of snow and ice on and near the surface. The multi-channel Coherent Radar Depth Sounder, or MCORDS, can penetrate the upper layers of snow and ice to reach the bedrock below, telling scientists the thickness of the ice. The Digital Mapping System, or DMS, is essentially 2 cameras mounted on the belly of the plane, capturing images every 10 seconds while the plane is in flight. New to IceBridge and the DC-8 this year is Columbia University's gravimeter. The gravimeter can distinguish the difference in gravity between rock, water, and ice to map what we can't see. Finally, the Land Vegetation and Ice Sensor, referred to as ELVIS, is best suited for high-altitude work. From 30,000 feet and higher, ELVIS scans a 2-kilometer-wide laser swath to provide a comprehensive map of surface characteristics. Perhaps the most impressive piece of equipment is the plane itself. DC-8 production was discontinued in the early 1970s, but NASA continues to utilize it for a variety of Earth science missions like IceBridge. This 4-engine workhorse can fly at 40,000 feet for over 12 hours at a time. Though the aircraft was not originally designed for low-altitude flying, it performs beautifully below 1,500 feet for IceBridge instruments. After a long day of flying, the ground crew meets the aircraft on the icy runway and prepares for another flight day. At the evening debrief, researchers and crew analyze the forecast for the following day and prepare to do it all over again. IceBridge is nearing the halfway point of the Arctic 2010 campaign. Next week, the DC-8 will return to Dryden Flight Research Center in California, where it will remain until this fall when it resumes IceBridge flights over Antarctica. For the remainder of the Arctic campaign in Greenland, NASA's P-3B airplane will deploy from Wallops Flight Facility in Virginia to Sondrestrom Air Base in southern Greenland. Science instruments aboard the P-3B will complete the remaining flights for this installment of IceBridge.